This is algebra 2, lesson 5.5, completing the square. Again, this is when we looked at undoing perfect trinomials last week by taking the square root of the first one and the square root or the square root of a and the square root of c. This is going to be an instance. We're going to create perfect trinomials beginning on page 282. First thing is actually the definition of completing the square. It's the process that allows you to write an expression in the form x squared plus bx as the square of a binomial. So we know that standard form says ax squared plus bx plus c. What we're going to do is we're going to start off by finding out what that plus c is. Okay, and then when you make it a square of a binomial, it's going to say x plus something, or in this case, it'll be the square root of this one and the square root of what that c is. So the square root of c, and then it'll be squared. So it'll be the square root of a binomial, just like we did with the perfect trinomials. So find a value of c that makes x squared plus 12x plus c a perfect square trinomial. So in order to find the value of c, you take b, you divide it by 2, and then you square it. Now, when you have nice, neat numbers, especially numbers that are even, it makes this very, very simple. When you have fractions, it complicates things just slightly, but it doesn't make it impossible. Watch when we get to one like that. So x squared plus 12x plus c. Notice that b's value is 12. So take 12, divide it by 2, and you get the number 6. And it's all of that squared. We know that 6 squared is the number 36. So in place of c, we're plugging in positive, or in this case plus. It's always going to be positive since you're squaring it, 36. So 12 divided by 2, which is what I did off to the side, is 6. And then 6 squared is 36. Okay. Use the c value to write it as a perfect square. So now what you're going to have is x squared plus 12x plus 36. That's our c value we just plugged in, plus c. Then when you take the perfect square trinomial, you take the square root of a, which is x squared gives you x, and the square root of c, it's 36. So we know the square root of that is 6. It's still the sign in front of b. It's still plus, and then you square that. So you take x plus 6, and x plus 6 squared is the square of the binomial. Okay, this is a new concept for you, but it's not a very difficult one, so don't be frustrated if it looks confusing. It's not. You just have to do it a few times before you get comfortable doing it. In fact, let's do it one time right here. Find c, and then write it as a square of a binomial. It'll take about a minute to do that. Remember, b divided by 2 squared gives you c. Don't get that confused with finding x for the vertex. X was negative b over 2a. That's not the one we're looking at right now. It's this one. Find c. They're very similar. Take about a minute. Okay, let's take a look at it. First thing you want to do is you want to find c. It's ax squared plus bx plus c. C is the unknown one. Now we're going to move numbers in a few minutes. We're going to move that value out of there in place of c, and we're going to find a new c, and I'll show you exactly what to do. But right now you take in b's value. B is negative 3. It doesn't matter that it's negative because we're going to square it, and when you square a negative value, it's going to turn out to be positive. But it's still negative 3 over 2 squared. Now, again, this is an odd number, -3, so it doesn't give you a nice integer value. So what you need to do is you need to make sure to square both this number, -3 squared we know is -3 times -3, which gives you 9, and square that number 2, and 2 squared is 4. So your C value is 9/4. So that was the first thing you had to do, was find the C value. The perfect trinomial will look this way. X squared, that's your normal x squared, minus 3x, that's the B value that you had already, minus 3x, and then all you're going to do is you're going to plug in your value of C you just found, plus 9/4. This is a perfect trinomial. The second part says, then write it as the square of a binomial. That's, again, that's very simple. It's just new. Take the square root of A. It's x squared. That means it's going to be x. Take the square root of C. Okay. The square root of 9, we know is 3, and the square root of 4 is 2. So notice it goes right back to being 3/2. And then the sign in front of B is the one that goes in between them, minus. So x minus 3/2 squared. That's it as a binomial square. This next one says find the value of C. Same problem with different numbers. Again, you got an odd number for B, so you have to do the same thing. Take about 30 seconds and find C real quick, and then we'll pick it up from there. Remember, C is B/2 squared. Find C. Okay, B's value is -5 in this case. So C equals -5/2 squared. Again, you can't get a nice integer number because it's an odd number, -5. So take the square of -5, which means -5 times -5. We know that's positive 25. And square 2. 2 squared is going to be 4. So your C value is 25/4. That's step one. Find C. So when you write it as a perfect square trinomial, it's ax squared plus bx plus c, we just found out, is 25/4. Then it says write it as the square of a binomial. Again, real simple. Take the square root of this one, of a, and it's x. Take the square root of this one. We know we can separate that into the square root of 25, which is 5, over the square root of 4, which is 2. So 5/2. And then it's the sign in front of b, which is minus, and the whole thing is squared. X minus 5/2 squared. If you FOIL that out, you're going to get back to the x squared minus 5x plus 25/4. Example number 2 is solving a quadratic equation. So you have to go one step further with this. Okay. First off, you can look at this example that says 2x squared plus 8x plus 12 equals 0, and you can notice that they all have the common term 2 in them. So when you divide the whole equation by 2, notice it says 0 on the other side. When you divide 0 by 2, you still get 0. You cancel out all of those 2's. So a lot of us try to think of it as this way. 2 times x squared plus 4x, because 2 times 4x is 8x, plus 6. That's the way a lot of us think of it that way. They just didn't write it out that way because they canceled out that 2. So now we have x squared plus 4x plus 6. Again, though, you can't do it like we looked at last week. You can't factor it out and do x times x because your values, your factors of 6, 1 and 6 and 2 and 3, neither pair of those get you to b. That's the reason you can't factor it out. So you have to do what's called completing the square. So you take that equation, x squared plus 4x plus 6 now, since we got rid of the times 2 version, equals 0, and you complete the square. We're going to find a new value for c. But in order to find a new value for C, we have to move the old value for C over to the other side. Okay. We know how to do that already. We know how to undo plus 6. It's the way we've always undid plus 6 since the second month of Algebra 1. You subtract 6 on the left. If you subtract it on the left, you subtract it on the right. Now what that leaves you with is x squared plus 4x equals negative 6. Now we want to find a new value for C. So it says x squared plus 4x plus C equals negative 6. And we want to find that value for C. You find C just like we did a minute ago. You take B's value, and you know that B's value is 4 in this case, because it's ax squared plus bx plus c. You take 4, you divide it by 2, and then you square it. This is a lot better version than the ones we just looked at for the simple reason that it's going to be a nice even number. 4 divided by 2 is 2, and 2 squared is going to be 4. So your new C value is going to be plus 4. Now the next line, I don't like the way they have it written, so I'm going to scratch it out in a second, but it's going to be confusing to you. But the thing you have to remember about this is anytime you add something to one side of the equation, just now we just added plus 4. It got heavier on that side of the equation. In order to fix it, we have to add 4 to the other side as well. So now we have x squared plus 4x plus 4 equals negative 6 plus 4, which is going to be negative 2 on that side. And this is the part I wanted to, don't write it like that. Just simply write it as plus 4, because that's confusing to write it as 2 squared, and it doesn't help you at all. So x squared plus 4x plus 4 equals negative 6 plus 4. That's what we have out there on the right. Okay. Again, when you take negative 6 plus 4, you're going to get negative 2 right there. And then when you take the square root of this a value, you get x. When you take the square root of your c value, you get 2. The sign in front of b tells you what goes in between them. It's plus. So x plus 2 squared is equal to negative 2. And then you treat this just like our bell work problems at this point. Undo the fact that it says x plus 2 squared. We know how to undo that. We take the square root of it. So take the square root of it, and it'll cancel it out. If you take the square root of the left, you take the square root of the right. Now, before last week, right now, there would be no real number that makes this right. But we know how to get rid of a negative in a radical. We take I out, just like last week. So now we have x plus 2 equals plus or minus the square root of negative 2. Okay. Again, we know how to take the negative value out. In order to take that negative out, you just multiply it by I. And you undo, it's just 2 steps in one, you undo plus 2 on the left to get x by itself by subtracting by 2. And do it on the right as well. And notice this is in standard form. It's a plus bi. So x is equal to, I know I wrote all over it, negative 2, since you subtract 2 on the left and the right, plus or minus I times the square root of 2. Remember, don't let the negatives bother you. Remember, I is like the easiest thing in the world to do. Just take the negative out by multiplying it by the imaginary number I. Okay, let's do the same thing for this one. First thing you want to do is move over that negative 8 and find a new value for C. Take about 30 seconds and do that. Okay, so again, we're doing this one in steps. Move over this value of C that doesn't work because you can't factor it out. So move it over by adding 8 to both sides. So now what you have is x squared plus 6x plus our c that we're going to find in a minute equals 8. In order to find c, remember, take b and divide it by 2 and square it. Our b value we know is 6. So 6 divided by 2 is 3, and 3 squared is 9. So our value for c is plus 9. But if you add 9 to the left, what do you have to do to the right? You got to add it. You can't just throw a plus 9 on the left without doing it to the right as well, or it won't work. So now all we got to do is combine these two, and we get the number 17. And take the perfect trinomial, take the square root of the first one, you get x. Take the square root of the third one, you get 3. This sign says plus, and you square the whole thing. So we're almost there. So in order to find this one out, just undo the fact that this says x squared by taking the square root. If you do it there, do it here. It cancels this out and leaves you with x plus 3 equals the square root of 17. And then undo minus 3. I'm sorry, undo plus 3 by subtracting it. So that's not going to give you the square root of 14. Remember, it just gives you x equals negative 3 plus or minus the square root of 17. And again, as ugly of a number as that looks, that's an exact figure. Okay, the checkpoint says x squared plus 4x plus 1. Take about a minute and try to get this one done. Remember, you want to find c, move the other one over, find c, and then take the square roots of your perfect square trinomial. Okay, went a little bit longer with this one. Okay, the first thing you want to do is move plus 1 over by subtracting it. If you subtract 1 on the left, you have to do it on the right. So what it gives you there is it gives you x squared plus 4x equals negative 1. Then you want to find a new c value. Remember, c is b divided by 2 squared. So b in this case is 4. So 4 divided by 2 we know is 2. And 2 squared, our new c value is going to be 4. So when you put in plus c on the left, you have to make sure to put in plus c on the right. Anytime you do something to the left, you got to do it to the right, or your balance is going to be thrown off. So from there, here's where your binomial comes from. Take the square root of a. X squared square root is x. Take the square root of c. The square root of 4 is 2. This sign is what goes in between them, the one that's in front of b. So x plus 2 squared equals, combine these two. Negative 1 plus 4 is positive 3. Okay. We know how to undo squaring something. You take the square root of it. If you do it to that side, you do it to this side. It cancels it here. X plus 2 is left over, equals the square root of 3. Almost finished. You have to move over plus 2 by subtracting it. And if you subtract it on that side, subtract it on this side, it's not going to give you the square root of 1. Remember, one of them's a radical, one of them's not. So you simply write it as x equals negative 2 plus or minus the square root of 3. Yep. And again, this is new stuff, but it's not extremely difficult. You can see by all of these numbers, none of those numbers got bigger than 4 just now. Yeah. Okay, and then example number 3 is writing quadratic function in vertex form. So what we want to do now is we want to complete the square. We want to complete the square. It's actually easier if you just go ahead and do, instead of doing it just like this, if you go ahead and do it like we've been doing it. Move over to plus 7. So y minus 7 when you subtract it on both sides equals x squared plus 6x. We're going to find plus c and put it right there. We know c is b, which is 6, divided by 2 squared. 6 divided by 2 is 3, and 3 squared is plus 9. Again, if you add 9 to the right, add 9 to the left. So now you have 9 and minus 7 you can combine on the left, and you get y plus 2 equals, that's a perfect trinomial on the right, because you could take the square root of the first one and get x. You could take the square root of the third one and get 3. You know the sign in front of b is going to be plus between them, and it's going to be squared. It's almost in vertex form. You only have one more thing to do for this one. Okay, you see how it says plus 9 and plus 7 on the right? Just that's why I don't like doing it that way. Just have it say plus 2 and just scratch out that plus 7 part. Okay, and then that way you can follow. You can do it just like the ones we just did. And then undo to get y by itself. Undo plus 2 by subtracting 2. And you get y equals x plus 3 squared minus 2. Again, you can't take 2 away from the positive 3 because it's in parentheses. This is vertex form. X plus 3 squared minus 2. Remember, it's the opposite of whatever this one says right here. So your vertex is going to be negative 3, and it's exactly what this one is, minus 2. So negative 3, negative 2. So you know when we graph this function, you know the vertex is going to be at negative 1, 2, 3, negative 2. It's going to be right there. That's going to be, since this is a positive a value, is it going to open up or down when I graph it? Is it going to look like this or like this, up or down? It's going to open up since it's positive. Like a U, it'll open up. Okay, see if you can get this one in vertex form. Do it the same way. Take about a minute before we get run out of here. That's vertex form right there. X minus h squared plus k. the first thing you want to do, just so we don't get run out of here on time, first thing you want to do is move 16 over by subtracting it. So now y minus 16 equals x squared plus 6x plus c. In order to find c, you take 6, the b value, divide it by 2 and get 3, and then square it and get plus 9. Remember, if you add 9 to one side, you got to add it to the other side, plus 9. So 9 minus 16 is y minus 7 equals, take the square root of this one is x. The square root of this one is 3. This says plus in the middle. We almost finished. Y, move minus 7 over by adding it, equals x plus 3 squared plus 7, vertex form.